Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section IT 2105. So this video is all about the summary of the chapter 4 entitled Network Access. So the first one that I will discuss to you about is the connection. So the first one is the physical connection. A physical connection can be wired connection using a cable or a wireless connection using radio waves. So you can use the wired connection. So you will use the cable and the wireless connection, and then you will use just the radio waves. So the next one is network interface card. So it connects a device to a network. So we use the NIC or the network interface card to connect a device to the network. So the next one is the physical layer media. So there are three types of physical layer media. So the first one is the copper cable, the fiber optic cable, and the wireless. So let's start with the first one, which is the copper cable. So copper cable, the signals are patterns of the electrical pulses. So it's electrical pulses. Then the fiber optic cable, the signals are patterns of light. So if the copper cable uses patterns of electrical pulses, the fiber optic patterns of light. Then it also become very popular for interconnecting infrastructure network devices. Then the last one is the wireless. So the signals are patterns of microwave transmission. So the physical layer standards are implemented in hardware and government by many organizations, including the ISO, the EIA or the TIA, then the TIO-T, the ANSI, and the IEEE. Then physical components. So are the electronic hardware devices, media, and other connectors that transmit and carry the signals to represent the bits. So the next one is encoding. So encoding is a method of converting a stream of data bits into a predefined code. Encoding is a method of converting a stream of data bits into a predefined code. So codes are grouping of bits used to provide a predictable pattern that can be recognized by both the sender and the receiver. So the next one is the signaling. So the physical layer must generate the signal optical, electrical, or wireless signal. So that represents the 1 and 0 on the media. Then the throughput. So it is the then the throughput. So is the measure of the transfer of bits across the media over a given period of time. So many factors influence throughput, including the amount of traffic, then the type of traffic, then the latency created by the number of network devices encountered between the source and destination. So there's a lot of factors that can influence the throughput. So there's different types of traffic and amount of traffic. So the latency refers to the amount of time to include delays for data to travel from one given point to another. So, there are types of physical media. The physical layer produces the representation and groupings of bits as voltages, radio frequencies, or light pulses. So, as an example, standards for copper media are defined for the uh, type of copper cabling used, bandwidth of the communication, type of connector used, pinout and color codes if of connections to the media, maximum distance of the media. So, characteristics of copper cabling. So, network use copper. As I said a while ago, so we use the copper cabling in network. So, network use copper media because it is inexpensive, so it's cheap, easy to install, and has low resistance to electric current. Then, the copper media has three main types used in networking. So, they are the unshielded twisted pair or the UTP, the shielded twisted pair or the STP, and the co-shell. So, let's start with the UTP or the unshielded twisted pair. So, it is the most common networking media. UTP cabling terminated with RJ45 connectors is used for interconnecting networks host with intermediate networking devices such as switches and routers. So, the UTP is the most common copper networking media. So, next one is the outer jacket. So, this one is the parts of the UTP. So, there's an outer jacket. So, it protects the copper wire from physical damage. So, it protects the wire. Then, the twisted pair. So, protects the signal from interference. Then, the color-coded plastic insulation. So, as we can see in the cable, some of it has different colors. So, electrically isolates wire from each other and identify each pair. So, for us to easily identify the wire, we use their color. Then, let's proceed to the shielded twisted pair cable. So, it provides better noise protection than UTP cabling. So, however, compared to UTP cable, STP cable is significantly more expensive and difficult to install. So, as I said before that UTP is inexpensive and easily to install. So, while the STP or the shielded twisted pair is expensive and hard to install. So, like UTP cable, STP uses RJ45 connector. So, their similarities are they use RJ45 for their similarities are they use RJ45 connector. The next one is the coaxial cable. So, consists of copper conducting used to transmit the electronic signals. So, a layer of flexible plastic insulation surrounding a copper conductor. So, the insulating material is surrounded in a woven copper braid or metallic foil that acts as the second wire that circuit and has a shield for the inner conductor. So, the wireless installation. Coaxial cable attach antennas to wireless devices. So, if we are going to install the wireless, so the coaxial cable is attached to the antenna of the device. So, the next one is cable internet installation. So, cable services provides internet connectivity to their customer by replacing portion of the coaxial cable. So, that's it for the chapter 4. So, chapter 4 is it's like about network. How the net what we use cable for the network. So again, this video is all about the summary of chapter 4. So thank you for watching.